Once again, good morning, good afternoon. Thanks for joining the webinar today on AquiferTest version 2015. My name is Wayne Hesh. I'm the product manager for AquiferTest and Visual Modflow. We'll get started. I believe there's a few people that are still joining, but I don't want to keep you on the line too long. Some brief comments about using Webex, which is the format for the session today. I have the microphones muted to prevent audio feedback, so if you'd like to send me a question or a comment, use the chat option, which is available on Webex. If I'm unable to answer your question, or if you have something that comes to mind afterwards, feel free to send me an email. My address is shown on the screen there. And we'll have a recording available in the next couple of days, which you can download and share if you wish. And the link for that will be available on the blog on our website. Hopefully everyone can hear me okay and you can see the screen. If not, then send me a quick chat message or double check your audio connections. So I'm really excited about the new version of AquiferTest. We've made a number of significant improvements, which we'll go through in the webinar for the next 20 or 30 minutes today. The first is that you can now analyze the wider range of test conditions. So we've added support for a new slug test, the Dagan method, and the new pumping test analysis based on the Neuman-Witherspoon. We've added the well efficiency plot, which allows you to gain more insight into your production wells and your site and your test conditions. We've improved the test interpretation and the analysis methods, so we've added a number of improvements to the diagnostic plots, flow regimes, and we also have a new pumping test solution advisor. And in general, we've improved the overall usability and the look and feel. So there's a nice option for importing data logger files. We've improved the licensing scheme, and also AquiferTest is now compatible with Windows version 8.1. So we'll go through each one of these in a little bit more details. Again, if you're late joining the session, just feel free to send me a chat question as we go along. The microphones are muted, so if you have something, I'll do my best to answer as we go along. Otherwise, just feel free to save your questions for the end. So this new version, we've added support for the Neuman-Witherspoon method, which allows you to analyze pumping tests from leaky confined 2 aquifer systems. With this analysis method, it includes the drawdown from the unpumped aquifers, which means it gives you further means to validate your pumping test conclusions. So this method has extended the capabilities of the hand-touche method, which are based on leaky aquifers, which would include storage or no storage in the aquitard. This method now allows you to interpret drawdown in the unpumped aquifer. The type curves are matched to the drawdown data collected in observation wells, and these observation wells may be screened in the pumped aquifer or the unpumped aquifer. So with this method, you can estimate the transmissivity and storage for the pumped aquifer, the transmissivity and storage for the unpumped aquifer, and also the hydraulic resistance, or the C parameter of the aquitard, and this can be used to calculate the leakage factor. So some options with this method: the pumped aquifer can either be the top or the bottom one, but not both aquifers simultaneously. For each observation well, when you're specifying the parameters, you need to specify if that observation well was screened over the pumped or the unpumped aquifer. And as you do the analysis and the fit, you'll see the adjustment or the estimate for the parameter values shown on the screen here. So for each observation well, you'll see those parameters I mentioned before, the T and S for the pumped and unpumped aquifer, and also the hydraulic resistance. This is the option here where you specify if the observation well is screened in the pumped aquifer or the unpumped aquifer. So there's an example of this project included in the examples directory once you install AquiferTest 2015. I believe it's called 2aquifersystem.hyt. You'll see something similar to that's shown here. The type curve parameters, if you wish to add a type curve on the analysis plot, are shown on the right side here, which are available down at the bottom of the analysis plot options. And the type curve parameters allow you to specify the beta or the leakage factor for both the pumped and the unpumped aquifer, the ratio for the storage for unpumped over pumped aquifer, and also the ratio for the storage for the aquitard over the pumped aquifer. I encourage you to check out the references that are shown on the slide here for more details on how we've implemented this solution and the assumptions and further examples on the validation. Second improvement for the analysis techniques is the addition of the Dagan slug test method. This analysis is appropriate when you have wells that are screened across the water table in an unconfined aquifer, and it should only be used where the length of the well screen, or large L, is much larger than the well radius itself. And the recommendation is that the ratio of screen length over the well radius should be greater than a value of 50. This one's pretty straightforward. There's not too much additional parameters here. It's for the most part similar to Horslab and Bauer-Rice slug test methods. You'll see your estimate for your hydraulic conductivity in the analysis panels here, and you have all the similar settings for doing your manual and automatic curve fit. More details on this method are available in the paper that's shown here. Likewise, there's an example available with the AquiferTest in the examples folder. This project here I've included is from the project called slugtest2.hyt. In this example, the screen length over the well radius was roughly 150, which satisfies the criteria as mentioned in the previous slide. And you'll see in the results that it matches pretty closely with the Horslab of roughly 0.6 meters per day, and slightly higher than the Bauer-Rice estimates of 0.5 meters per day. The other significant improvement in this release is the addition of the well efficiency plot. So this one allows you to determine the efficiency of your production well based on the defined pumping rate and the well loss analysis that you've done. Generally, well efficiency of 70% is considered acceptable. Other publications mention that a well shouldn't be any less than 65% efficiency. So the plot that we do here is just a simple plot of well efficiency V versus the discharge rate Q. The efficiency is calculated as shown on the screen there, and generally as you go higher in efficiency, then the pumping rate is going to diminish accordingly. There's a number of settings that are available for this one, but before you do a well efficiency plot, first you need to create a well loss analysis based on the Hand-Touche-Biershank method, and there's a number of examples that are available with the AquiferTest installation. So first you do a well loss analysis, and this allows you to determine the B and C coefficients, which are the linear and the nonlinear well loss coefficients. Those are shown in the screen in the top right here. And if you try and create a well efficiency plot without first doing this, then the program is going to show you a reminder message to say that you first need to create a well loss analysis. If you're unfamiliar with these well loss analysis, there is a tutorial available in the AquiferTest installation along with a sample data set that tells you which data requirements are necessary. Once you've created that, then you can simply choose the menu option to create a new well efficiency. From there, you can choose the desired efficiency rate and see what discharge rate would be required in order to achieve that. And the program will plot a simple XY plot with the well efficiency on the Y-axis and the discharge along the X-axis, and plot that discharge and efficiency location on that plot. From the settings panel on the right side of the screen, if you click on this button that's highlighted here, it allows you to specify the desired efficiency in a little pop-up window, and the program will then calculate what discharge is required in order to achieve that efficiency. So again, this is a pretty standard reporting requirement for production wells, and it should be a nice improvement to the software in complements with the well loss analysis and the specific capacity tools. The other improvements we've made would be as they relate to diagnostic plots. So the previous version of AquiferTest, these diagnostic plots only worked with constant rate discharge tests, so we've removed that limitation. So now you can display these diagnostic plots for variable or variable rate discharge test, which is ideal for step test analysis. You can also include the recovery periods for both recovery after the pump's been turned off or even recovery periods during the step test intervals. In addition, you can display trend lines, which represent a variety of flow regimes, which are ideal for determining different well or aquifer conditions throughout the stage of the pumping test. And these diagnostic plots were really going based on something that's been tried and tested and true in the oil and gas industry, where these diagnostic logarithmic plots have been used for a number of years for well test interpretations in those applications. The corrections that we've done for both variable discharge rates and recovery periods are based on the reference down at the bottom of the screen, based on Beersoy and Summers. There's a publication in Groundwater from 1980. I can send anyone the link if you're interested in that. So those options for enabling variable discharge and recovery are available at the top of the screen here. You need to turn on those checkboxes if your test data includes those data sets. Here's an example for a variable discharge test where you can see that the pumping rate changes throughout the course of the test, and the water levels were calculated at a variety of different pumping rates. In the previous version, without the correction for variable discharge rates, it would be difficult to determine the trends and identify various well and test conditions from a discharge rate test. You get kind of a mix match of data set at the top of the screen here. Now with the improvement in the latest version, when you turn on the option for variable discharge rate, you'll see that the data set is much more meaningful and can be interpreted and compared to these diagnostic plots that are shown along the right side of the panel here. In addition, in this diagnostic graph, you can display these flow regime lines that I mentioned in the previous slide based on well-known and documented examples in the petroleum industry. You simply choose the various flow state regimes from this drop-down list in the program. We'll plot a set of lines across the screen. So there's various flow states based on radial flow. The one that's shown here indicates that you have wellbore storage, but you can also plot flow regimes for linear flow, bilinear, or the less common spherical flow. There's a custom option where you can simply enter the slope of the line, and the program will plot these flow regimes right on the screen for you. So these are useful for comparing the drawdown derivative data only, and it should only be used when you're working in the logarithmic scale. As mentioned, it'll plot a series of lines which have particular slopes that represent slopes of the drawdown derivatives during that time period. And these lines should be parallel with the derivative of the measured data that you've indicated there. So you can see from this example that by comparing these lines for wellbore storage in the early phase of the test, that you can see that the test data exhibits those conditions. Each one of these flow state regimes are explained more online. I encourage you to take a look at the reference that's shown at the bottom of the screen, since we've, with the most recent releases, been adopting some of these tried and tested and true techniques for diagnostic plots, and you'll see further improvements with this aspect in future releases of the software. One other improvement we've made in the next version, or sorry, in the new version, is the addition of the pumping test advisor, which was a feature we had in a much older version and has been requested for a number of releases. So we've added this option back in and updated it to reflect the most up-to-date solution methods that we have available in the program. So this solution advisor allows you to choose the most appropriate pumping test solution method based on your test conditions. It takes you through a series of simple yes/no questions, which is based on an online flash technique. And at the end, it'll recommend an appropriate solution method based on the answers that you gave. This is available from the help menu as shown on the screen there. As I mentioned, it only works for pumping tests, but it'll go through each aspect of the pumping test, whether or not you have single or multiple pumping wells, if it's isotropic, anisotropic, if you have unconfined, confined, or fractured aquifer, etc. So I encourage you to use this if you have any doubts in terms of what assumptions are used for a particular method. And at the bottom of for the answer for each of the methods, it'll provide a reference and a summary for the method that's available with more details on that particular method and the according assumptions. Another improvement we made is more streamlined and efficient import of water level data from data logger files. So with the previous release and the current one, we also have the data logger import wizard, which allows you to quickly import data logger files from a diver data logger or from other pressure transducers that use file formats such as ASCII or text. What we've done in the latest version now is you can save the data logger wizard import settings and use that as what's called a DropZone, and it really makes it quick and easy to import data logger files. So once you've mapped your import wizards for your particular data logger, it's just a matter of selecting your file from within Windows Explorer, and you just drag that file right into the panel within the program in the DropZone, which is shown in the Water Levels tab on the right side of the screen here. And based on the data logger file that you chose and the mappings, the program will automatically import that file for you without having to go through and map during the wizard each time. So there's a simple example for a diver data logger that's included with the installation. If you look in the exercises folder, there's a file called diver example, which is a MON file, and you can simply drag that into the DropZone and drop it on the microdiver panel, which I've highlighted here, and the program will automatically import that data for you. So it's a very quick and easy way to load multiple data logger files which follow a similar format. If you're always using the same pressure transducer or the same data logger for a variety of tests, it can be a significant time saver. So as mentioned, in order to configure this option, first you need to go through the data logger file wizard once with your specific data logger file. At the end of that wizard, be sure to save the settings as an option or as a template for reuse, and that will then appear as a new panel on the DropZone on the previous screen. So if you go through and save your logger wizard template as a file called test, that new test template will appear on the DropZone panel with the name test in the panel shown here. Once that panel is there, you simply can drag any additional files onto that panel, and the program will import it automatically for you. There's a couple of different options if you want to use this DropZone, which you need to correctly configure in the Tools Options window. So there's two options. You can use the date and time from the file as the starting point or as time equals 0, or you can use the date and time value that's specified in the test as the time equals 0. So be sure that you choose the correct option or set the appropriate date and time in the settings before you use this option. Otherwise, your data may not load in correctly. So some other improvements we've made, as I mentioned, we've tested the latest version of AquiferTest, so it's now compatible with Windows 8.1 and certified for Windows 8.1. We've improved the licensing system, so it's now fully automated. This means that you can just go through a series of online registrations for your serial number and your name and email address and submit your license request, and your license file will be sent back to you automatically. So you no longer need to wait for your license file to arrive in the email within a day or two. So this is done now completely automated. And lastly, the program GUI look and feel has also been updated. I can show you what that looks like. We have a variety of new icons and updated panels. We've improved the well profile and illustrations down to the bottom of the screen here. You'll see the icon set has also been updated. You would have seen in the previous slide where I've updated the, we've updated these diagnostic plots with improved images here, so it allows you to better interpret your test or well conditions. All right, that brings us to the end of the webinar. As I mentioned, there's a lot of exciting improvements in this version. We're always looking for your comments or suggestions for future releases, so please feel free to email me if you have any suggestions or questions about things we've added or suggestions for new analysis methods. If you have any questions at this time, I'll take those through the chat option.